Hello everyone. In today's video, I'd like to go over an interesting challenge question. I'm going to say I have a 5-meter piece of wood. Okay, so the length of my board is 5 meters. And then on top of this board, I have an object on this side that weighs 10 kilograms. And I have an object on the other side, and we'll say that one weighs 8 kilograms. Alright, so I have these two objects, and what I want to know is how far from the red box should I place a fulcrum to balance this board? So how far from the red box should I place a fulcrum? All right. Well, let's try to figure it out. So I have some location on this fulcrum. I'm going to draw it in the middle for right now, just so I have some visual idea where I'm going to have a fulcrum. All right. It will not be exactly in the middle, but it's going to be some distance between the two objects. At that point, my object's going to pivot. Okay, one object, the blue one, is going to try to rotate it this way, and the other object, my red one, is going to try to rotate it the opposite way. So I want the torque from these two objects to be the same. So as we mentioned yesterday in that video, I want the torque counterclockwise to equal my torque clockwise. Okay, my red one is going to rotate it clockwise, my blue one will rotate it counterclockwise. Now, to find torque, I need the force of the blue box times the distance of the blue box. And I need that to equal the force of the red box times the distance of the red box. Now, if I look at what I'm given, what I know the mass of the blue box, and I would know the acceleration due to gravity on the blue box. I know the mass of the red box, and I know the acceleration due to gravity on the red box, so I can figure out my forces. So since force equals mass times acceleration, I have mass times acceleration times the distance of B. So this would be the mass of B. And that's going to equal the mass of the red box times the acceleration due to gravity. I'll make that G. Times the distance of the red box. Now, the tricky part here, when I start plugging in my numbers, I'm missing two of my variables. I'm missing both distances. I don't know how far those are from my pivot point. So let's go back to our question. I want to know how far from the red box they are. So what I want to solve for is this distance. I'm trying to solve for dr. Okay, so I definitely want to have dr. Now, I need to figure out my relationship between dr and db. So if dr takes up this distance from the fulcrum, wherever it will be, to the end of the board, how much is left for the blue box? How much distance would be left here? Well, if my whole board is 5 meters, and the red box is going to be some distance dr, then dB is going to equal 5 meters minus the distance the red box takes up. So using that, I now have just one variable. So let me plug my numbers in here. So the mass of the blue box is 10 kilograms times my value for the acceleration due to gravity, 9.81, times the distance of the blue box. I'm going to use this, 5 minus the distance of the red box. That's going to equal, well, the mass of the red box, should be 8 kilograms, times, again, the acceleration due to gravity, 9.81 meters per second squared, times the distance from the red box to the fulcrum. Now, I have one variable and a bunch of numbers, so now we can just start solving. So I have 98.1 times 5 minus dr is equal to 78.5 dr. All right, now I got to distribute over here. So I have 98.1 times 5. So I have 491 minus 98.1 dr equal to 78.5 dr. Okay, so I need to get rid of this over here, so I'm going to add 98.1 dr to both sides. Looks like I dropped my capitalization here. dr. All right, there we go. So that means this goes away. And I'm going to come over here. So 491 is going to equal 78.5 dr plus 98.1 dr. So it equals 177 dr. Now all I need to do is divide both sides by 177. And I get an answer of dr equaling 491 divided by 177. So 2.77 meters. That is the distance from the red box to the fulcrum. So let me redraw my image over here. So I have my red box, and it is going to be a little bit more than half. 2.77 meters into my 5-meter stick, which would mean my blue box, which is more massive, would be the remainder of that. And the question doesn't ask it, but just for the sake of it, 5 minus 2.77, that will be 2.23 meters. And that's where I would want to place my fulcrum to balance everything out.